We have one more topic in trigonometry. It deals with oblique triangles, which are non-right triangles, and that sounds more difficult, and sometimes it is. But this first topic, law of sines, I think you're really going to like it. It's very simple, it's straightforward, and you can use it with right triangles as well as non-right triangles, which a lot of students, in my experience, turn out finding very easy. So I need to tell you what the law of sines is. I'll briefly try to describe where it came from. Then I'm going to go ahead and jump into the suggestions and the common mistake that I see. Then I'll show you when we use the law of sines and examples that go along with those situations. So you should jot down either one of these or both. They both solve for unknown sides and angles in non-right triangles. And they work because they're reciprocals of each other. It's really up to you which one you want to remember. But in essence, what this says is we take this angle here. If we take the sine of that angle and divide it by the side across from it, that's equal to the same ratio of this angle and this side, this angle and this side. And of course, we could flip them over. We could do side over sine of angle, side over sine of angle. Doesn't matter. But the relationships exist between all three pairs of sides and angles. So where does this come from? And like I said, I'm going to try to be brief about this. It comes from dropping an altitude in the middle of a triangle. So let's say this is, 20 degrees and this is 10. And we also know that this is, like say 50 degrees. If we're looking for this side here, we could have used the sine of 20 to find, let's call that y. And then we could use sine again from the 50 degrees to solve for x. So instead of constantly drawing this middle line in here, we just recognize that there's a relationship between the sine of 20 and the side across from it, like there is between the sine of 50 and the side across from it. So jumping back to the suggestions and common mistakes, I'll remind you again when we get there, but we're also going to learn a thing called the law of cosines. I always recommend trying the law of sines first. Most people find it easier. If you don't, that's fine. You can flip that suggestion. The suggestion, which kind of leads to the common mistake, sometimes you'll think that the law of sines isn't going to work because you didn't solve for the third angle. And sometimes you need it. Sometimes you won't, but it's a really easy calculation, and so you might as well go ahead and solve for the third angle in case it does help you. We use the law of sines in three situations. We're only going to talk about the first two, angle, angle, side, and angle, side, angle. It's not super important that you memorize this, but some people find it helpful. Please, please, please write down this example. I see too many notes where people hand them in, and they didn't include the diagrams. I won't give you full credit if I don't see this diagram and the work that goes with it. To help us out, I'm going to label the three sides A, B, and C. And originally there are three ratios in the law of sines. I only need two, because I only need one ratio where I know both pieces of information, like the sine of A over A, and then I need another one where I know one piece of information and not the other. So this is my unknown right here. Filling in the information, I get the sine of 40 over 5 is equal to the sine of 60 over x. I'm going to do this all in my calculator. I'm going to do 5 times the sine of 60 and then divide by the sine of 40. And when I do that, I get an answer of 6.7 for x. Very simple, very simple. Cross multiply and divide. Here's one more example. So again, I'll label A, B, C. We'll do the sine of, well, here's my unknown. Sine of B over B has my unknown in it. So then I want something else where I know. Well, I know the sine of A, but I don't know the side across from it. Though I can subtract these two angles from 180, and I would get 60 degrees here. So actually, I want to do the sine of C over C, because I know both the angle and the side with just a little bit of work there. So I'm going to cross multiply. 6 times the sine of 70 is equal to x times the sine of 60. And then I'm going to divide both sides by the sine of 60. And I'm going to do this all in my calculator. And we get x equal to 6.5 in this case. One more case where now we're going to solve for the angle. So I'm going to do sine of A over A, because I know both of those. The other side that I know is across from B, so I'm going to do sine of B over B. When I fill in the information, I get sine of 35 over 22 is equal to the sine of B, which is our unknown, over 38. When I cross multiply and divide, I get 0.9907 for the sine of B, which means I need to do the inverse sine. So on my calculator, I'm going to hit second sine of that number, and then I get an angle of 82.2 degrees for B. In your summary, just jot down the law of sines and when you can use the law of sines, if you want to go back and jot down those three methods or those three cases, and that's pretty much it. Sorry for the lengthy video. Hopefully you'll find it easy when we practice it in class.